Okay, let's take a look at the quiz review for sections 8.1 and 8.2. Remember, it covers the Pythagorean theorem and special right triangles. So for the first one, remember the Pythagorean theorem says a squared plus b squared equals c squared, where c is the hypotenuse opposite the right angle. So we have 15 squared plus 8 squared equals c squared. 225 plus 64 equals c squared. So that is 289 equals c squared. The first thing you should try is check and see if that is a perfect square. And in this case it is. So c is equal to 17. The second one is also the Pythagorean theorem, but now we're given the hypotenuse and we're looking for a leg length. So I have 15 squared plus b squared equals 25 squared. So 225 plus b squared is equal to 625. b squared is equal to 400. Again, this is a perfect square. You take the square root and b is equal to 20. A couple more that are the Pythagorean theorem. Again, 7 squared plus b squared equals 17 squared. So 49 plus b squared is equal to 289. b squared is equal then to 240, so b is equal to the square root of 240. Now you want to try to find simplest radical form for this. So you have 240, and if you divide 240 by 15, you'll get that b is equal to the square root of 16 times the square root of 15. You can break 240 down into those two squares. 16 is a perfect square, so this becomes 4 square root of 15. And I do expect you to be able to give me simplest radical form. If you stop here, you'll lose half a point for not being able to simplify that. Okay, the second one, I have a squared plus 24 squared equals 52 squared. So a squared plus 576 is equal to 27,004. So a squared is equal to 2128. So a is equal to the square root of 2128. I'll try dividing that by 9. That didn't work. 2128 divided by 4 gives me 532. Divided by 4 gives me 133. So I think if I take 2128 divided by 16, so a is equal to the square root of 16 times the square root of 133. So a is equal to 4 square root of 133. Again, simplest radical form. You want to try to break that radicand into two numbers, a perfect square and a non-perfect square. Number 5 says list 3 sets of Pythagorean triples. You should always remember a 3, 4, 5. There's also a 5, 12, 15. You could also have a 6, 8, 10. You can always take a 3, 4, 5 and multiply it by the same scalar multiplier, and you would generate another set of Pythagorean triples. Next, classify the following triangles with the given sides as right, obtuse, or acute. Okay, so we have 7 squared plus 8 squared. How does that relate to 9 squared? So 49 plus 64 is greater than 81. That means that that is acute. The second one, 16 squared plus 48 squared. And how does that relate to 55 squared? So I have 256 plus 2304, and that is less than 55 squared, which means this triangle is obtuse. Number 8, 13 squared plus 84 squared, and how does that relate to 85 squared? 13 squared is 169. 84 squared is 7,056. And 85 squared is 7,225. They are equal. That makes this triangle a right triangle. Number 9. This, you're just using the distance formula in 3 dimensions. Remember, the distance is equal to the square root of x1 minus x2 squared plus y1 minus y2 squared plus z1 minus z2 squared. So the distance is equal to the square root of -3 minus 4 squared plus 2 plus 4 squared minus a negative makes that positive, plus 5 minus 10 squared. So I have -7 squared, which is 49, 6 squared, which is 36, and 5 squared, which is 25. So IS is equal to the square root of 110. That's not divisible by 4 or 9, so that's probably already in its simplest radical form. Number 10, now we're given some angle measures, so we're going to be looking at, again, a 30, 60, 90 triangle. Remember, the relationship is the hypotenuse is equal to 2 times the short leg. So the short leg is equal to the hypotenuse divided by 2. The long leg is equal to the square root of 3 times the short leg. Therefore, the short leg is equal to the long leg divided by the square root of 3. So now, when I look at number 10, I have the long leg and I need the short leg. So the short leg, A, is equal to the long leg 12 divided by the square root of 3. You must rationalize that denominator. I'm going to multiply that by the square root of 3. So A is equal to 12 root 3 over the square root of 9. Square root of 9 is 3. So 12 root 3 over 3 gives you an answer of A, 4 root 3. Remember the relationship between the short leg and the hypotenuse C, is equal to 2 times the short leg, which is 4 root 3. Remember, there's no radicand attached to that 2, no radical there, so you just multiply those coefficients and you get 8 square root of 3. So there we have A, the short leg, and C, the hypotenuse. Number 11, you're given the hypotenuse and you want to find the short leg. So remember, the short leg R is equal to the hypotenuse 30 root 3 over 2. Again, there's no radical there, so you're just going to divide those coefficients. So R is equal to 15 root 3. Then you're looking for the long leg, S. So the relationship is the long leg is equal to the square root of 3 times the short leg. So S is equal to the square root of 3 times 15 root 3. Again, put a 1 there if it helps. So S is equal to 15 square root of 9. Square root of 9 is 3. 3 times 15 would be 45. So the length of the short leg is 15 root 3. The length of the long leg is 45. Next we have a 45, 45, 90 right triangle. Remember the relationship is the hypotenuse is equal to the leg times the square root of 2. Therefore the leg is equal to the hypotenuse divided by the square root of 2. So in the first example, number 12, we have the hypotenuse. We're looking for the leg. So A is equal to 18 divided by the square root of 2. Rationalize the denominator. You'll get that A is equal to 18 root 2 over 2, which becomes 9 root 2. Also, this is a 45, 45, 90 right triangle. Therefore, A and B are equal, so B is also 9 root 2. In 13, again, I have a 45, 45, 90 right triangle. My legs must be equal, so B is equal to 5 root 2. Go back to your formulas. The hypotenuse C is equal to the leg, 5 square root of 2, times the square root of 2. Put a 1 there if it helps. Multiply what's outside together. You're going to get 5. The radicands together, square root of 4. Square root of 4 is 2. Therefore, C is equal to 10. So there is your A and B for 13 and your A and B for 12. Number 14 is a little more challenging. You have to draw an auxiliary line, which will be perpendicular to the base. So when you look at this, you have a 30, 60, 90 triangle. Therefore, A is the short leg. So A is equal to the hypotenuse, 24, square root of 5 over 2. So A is equal to 12 square root of 5. This is 2. B is the whole length, so we're going to have to find the length of the long leg. Let's call that C. So C will be equal to the short leg, 12 square root of 5, times the square root of 3. So C is equal to 12 square root of 15. B makes up these two sections, this little part, and then this length C. So B is equal to 2 plus 12 square root of 15. That's the final answer for that. You cannot simplify that. Just leave it. You can only add those if you have like radicands. 15 again, I'm going to draw an auxiliary line. That's perpendicular to the base. I have a 45, 45, 90 triangle. I'm going to find the length of this leg, or this leg, because they are congruent. So the leg is equal to the hypotenuse, 6 root 2, over root 2. So therefore the leg is equal to 6. So this is 6, and this is 6. Therefore, B is 6. Now for the next, I'm looking for A, which is here. A is just this part. If the entire thing is 15, then A equals 9. So B is 6, and A is 9. Number 16, a word problem. A zip line at the Acme Adventure Resort starts at a height of 32 feet. The line travels at a downward angle, delivering its passenger 60 feet from the base. So this is 60 feet. How far did the adventurer travel? So that would be C. So this is the Pythagorean theorem. 32 squared is 1,024 plus 60 squared, 3,600 is equal to c squared. So 1,024 plus 3,600 is going to be 4,624. First thing, now this is a word problem and we're talking about distance. So just take the square root of that 4,624. Oops, it's a perfect square, 68. So 68 feet is the distance that the adventurer would travel down the zip line. Next one says Sam walks home from school every day. The mean neighbor on the corner won't let her cross through his yard, so she must walk 50 feet on one side and 80 feet on the other side. So here's the 50 feet. Here is the 80 feet. How many feet could she save if the neighbor would allow her to cross through the yard? Okay, so we're looking for first the length of the hypotenuse, and then the distance she currently walks minus the length of that hypotenuse will give us the answer. So I have 50 squared, which is 2,500, plus 80 squared, which is 6,400, gives me c squared. So 8,900 equals c squared. Take the square root of 8,900 and you get 94.3. So we'll just round that to the nearest foot. For these word problems, we're going to round to the nearest foot. So then the distance saved would be 130 minus 94, or 36 feet. Number 18, a window has a diagonal of 18 inches, or excuse me, 85 inches. A window has a diagonal of 85 inches and a height of 84 inches. How wide is the window? We'll call that A. Again, this is the Pythagorean theorem. A squared plus 84 squared equals 85 squared. So I have a squared plus 7,056 is equal to 7,225. A squared is equal to 169, so A is equal to 13. So the window is 13 feet wide. Now, the next few are just looking at simplifying radicals. So when you look at this, you want to break this down into a perfect square and a non-perfect square. So you might try taking 180 divided by 4. When you do that, you get the factors 4 and 45. Well, 45 is also divisible by 9. So this becomes 9 and 5. Now take this non-perfect square and go back up, take 180 divided by 5. You will get the square root of 36 times the square root of 5, which is 6 root 5. So simplest radical form for number 19 is 6 root 5. Number 20, multiplying radicals. You multiply the outside together, then you multiply the radicands together. Simplify that if you can. You cannot simplify the square root of 10. When you have a radical in the denominator, multiply by the exact same radical. So here I'm going to have 4 root 2 over 2, which I can reduce to 2 root 2. That's called rationalizing the denominator. When multiplying, you just multiply the radicands together. So in this case, I have the square root of 7,500. That's not a perfect square, so I know 7,500 is divisible by 25. And that would be 25 and 300. 300 is divisible by 103. So again, I'm going to go back to that original 7,500 and divide by 3. That means I'm going to have 2,500 times the square root of 3. Take the square root of 2,500 and you will get 50. So the answer is 50 square root of 3 in simplest radical form. Look at 23. They don't have the same radicands. If they don't have the same radicands, you cannot add them together. Now, 125 is 5 to the third. So I have 4 times, actually, I want a perfect square, so that's 25 times 5 plus 2, square root of 49 times 2. 25 and 49 are perfect squares, so you can bring those out. Sorry, I wrote that as a 2, it's a 5. Plus 2 times 7, square root of 2. You end up with 20 root 5 plus 14 root 2. Stop there. That's the answer. You can't do anything to simplify that. Last one. Rationalize the denominator by multiplying by root 3. You're going to get square root of 15 over 3. Next, I think I had those already. We'll do 25 and 26. Again, multiply what's on the outside together. 5 times 2 is 10. Multiply radicands together, square root of 9. 10 times the square root of 9, which is 3, gives you 30. And finally, 26 becomes the square root of 100 times the square root of 3, or 10 root 3. Again, simplifying radicals, you're just looking for a perfect square and a non-perfect square. Thank you. See you tomorrow.